These directions ask us to find the rational zeros and then the other zeros, that is, solve for f of x equals 0, and to factor into linear factors. This is actually number 58 on page 340 if you want to take a look at the original directions in your book. Now, when we take a look at this one, the first thing that we want to do is find the possible zeros so we know what we're looking for. To find the possible zeros, we take the factors of 4 and the factors of the 1, which is the coefficient on the far left, and we divide them. When we think about the factors of 4, all the numbers that will go into 4 are 1, 2, and 4. The numbers that will go into 1, it's simply 1. Now, we have to think of each one separately. So we have to think of this 1, this top one over this bottom one, and this 2 over this 1, and this 4 over this 1. So that if you had a different set of factors, let me just put a different set down. Let's say if you had something besides a 1, you would have 1 over 1, 1 over 2, 2 over 1, 2 over 2, and 4 over 1, and 4 over 2. So you would have several factors to pull from then. In our case, though, let's mark this one out so we're not working with that one. We only have plus and minus 1, 2, and 4. Your next step is to take your polynomial, put it in your calculator, and look for a zero that matches one of your possibilities. We have 6 possibilities, so we're going to put this in our calculator and take a look at it. When you look at the graph, you see that it crosses the x-axis, it looks like at -2. That happens to be one of our possibilities, so we're going to go with that one, -2. And what you want to do is do synthetic division with that 0. Remember that to do synthetic division, you take all the coefficients of your polynomial. And remember, you put a 0 in when there's a missing exponent. So we're going to do synthetic division with this problem. We've done our synthetic division. We have a 0 at the end, so that's a remainder. So we have no remainder in this problem, so we know we can use it. Remember that when you do synthetic division, your answer starts with the next lower exponent. We go back up and we look at our original problem. We had a 3, so we're going to go down to a 2. Now this is what we got after we used our 0 of -2. At this point, if this was something that you could factor, you would factor it further. In order to find more zeros, you could take your calculator, put this one in it, and maybe find some more zeros by looking at it. If I put this one in my calculator, though, I find that this one does not cross the x-axis when I put in x squared minus 2x plus 2, and if it doesn't cross the x-axis, the remaining zeros are imaginary. We're only really concerned with finding the real zeros and the factor. So the real zero, the only real zero that we have is -2, and the factored version, if we go backwards from -2, is x plus 2, and the answer that we got when we did synthetic division. The bottom result is the factor, those are the factors, x plus 2 times x squared minus 2x plus 2. The zeros that we have right now, the real zeros, the only one we have is -2. If we wanted to find more zeros, we would need to take x squared minus 2x plus 2 and factor it or use the quadratic formula. In this case, if we try to use the quadratic formula, we get a negative underneath the radical, so we know that the other zeros are actually imaginary, so we don't need to find those. To find a polynomial with the given zeros, we must first go backwards and write the polynomial in its factored form. Remember that when we were trying to find the zeros, we set the factor equal to 0 and we solved. So in this case, we'll go backwards, and -2 will actually become x plus 2. And if we see that, if we have x equals -2, if we bring the -2 back over to the x, we get a plus 2. So x plus 2 is the factor that this 0 came from. If we're using the 0 of 3, we have a factor of x minus 3. It's just the opposite. And for the 5, we have x minus 5. Once we get it that far, we simply multiply everything out. X plus 2 times x minus 3, when we FOIL it, we get x times x is x squared, x times -3 is -3x, 2 times x is 2x, and 2 times -3 is -6. Combining like terms, we get x squared minus x minus 6. We still now have to multiply this by x minus 5. Distributing, we can still multiply the x squared times the x and the x squared times the minus 5, and then move on to the negative x, multiply it by both terms. So what we want to do is simply multiply here. We've multiplied x squared times x and minus 5. Now we'll do negative x times x and minus 5. And now we'll do the negative 6. Now we want to combine all of our like terms. Now we have the polynomial that our zeros came from. And if we took our polynomial and we factored it, we would get zeros of negative 2, 3, and 5. We could also put this in our calculator and look at the zeros, and we would get zeros of negative 2, 3, and 5. But because the question asked us to actually find the polynomial, we went backwards, we multiplied it all out, and we now have the polynomial that this came from.